Chemistry is the study of atoms, molecules, and their interactions. Now, virtually every process that happens in the universe involves molecules, atoms, and their interchange. So chemistry is going to take us from a study of atoms and molecules, their reaction in space, to the way atoms are formed in the center of stars, to earthbound reactions, the chemical reactions that we use to produce energy, or the chemical reactions that produce our food, and even those chemical reactions that happen in our body and help us maintain life itself. Let's start with a pretty simple chemical reaction. H2, hydrogen gas, plus O2, oxygen gas, to form water. And I've written this carefully with coefficient of 2 in front of the hydrogen. That says 2 hydrogen molecules will react with 1 oxygen molecule to form 2 water molecules. So this reaction, the formation of water from hydrogen and oxygen, is favorable. In fact, when that reaction occurs, energy is released. It can be very dramatic. So in a sense, the products, water, are lower in energy than the reactants. And we can plot that on a relative scale. And we'll do this a lot in chemistry. We'll plot energy on a vertical scale and the progress of a reaction along the horizontal scale. So in this case, it would look something like this: the reactants at a given energy and the products downhill at a lower energy. Now, in a mechanical example, you'd say, well, if there were a ball on the top of this hill, it would naturally roll down to the bottom of the hill. That's the natural way of things. And it's the same for this chemical reaction. The natural way is for hydrogen and oxygen to form water. There's a natural favorable direction of this chemical reaction. But there's one more interesting part, and that is if I take oxygen and hydrogen and I mix them together in a balloon, I can wait quite a while and never find water. I can come back and look at that balloon the next day, the next week, 6 months later, and it's still going to be a hydrogen-oxygen balloon. You won't find a balloon full of water. And why is that? Well, in order to form water from oxygen and hydrogen, we have to pull apart and strain the bonds that are holding the hydrogen and oxygen together in their own molecules, and then form the bonds that form the water molecule. That pulling and stretching and rearranging of bonds requires energy. So there's a high energy intermediate state between the reactants and products. We call that a high road barrier between the products and reactants. And you might say, well, if there's that high road barrier, why do they ever react? Well, let's go back to the mechanical example. If I had a ball here, could I get it to the other side of that hill? Well, sure, one way I could get it was to flick it, give it some kinetic energy, and have it roll up over the hill. If it rolls up over the hill, it'll have enough kinetic energy to overcome this potential energy and then roll down and even release more in kinetic energy than it had to start with. So it's possible in the mechanical example. Is it possible in the chemical example? Well, it is. I can't go in and flick individual atoms or molecules of hydrogen and oxygen, but I can get them to move faster, give them kinetic energy. I can heat them up. And throughout this course, we'll associate an increase in temperature with more molecular motion. So I can get reactants to have enough energy that some of them will react and go over this hill. And then it can become cooperative. They'll release some energy, they'll excite others in the mixture, and they'll all start to fall over that hill. So adding energy allows me to get over this hill. Now, there's a couple ways to do this. I could take a balloon, for instance, and fill it with hydrogen. If I fill it with hydrogen and then bring a flame to that, to add that heat source, what I'd find is the flame would first burn a little hole in the balloon, then heat up the hydrogen molecules, and then they could react with the oxygen molecules in the atmosphere. I could imagine doing it a different way, probably more efficiently. I could put the oxygen inside the balloon with the hydrogen to start with. Now they're intimately mixed, and when I bring that flame, they're ready to react. So both those would be interesting, And in fact, a lot of these chemical reactions release energy and they're fun to watch. And we'll watch a lot of chemical reactions through this series. The hydrogen-oxygen reaction is one that I find most interesting, and I think you will too.